Hey guys, today we've got section 5.3. So we have a couple more formulas that are going to be added to the back of your unit circles, and these are sum and difference formulas for cosine. So what I want to draw your attention to here is the way that these are a little bit tricky is that if we're doing the cosine of two angles added together, the formula is cosine A cosine B minus sine A sine B. So be careful about that little switcheroo. If you're subtracting two angles of cosine, you are adding in the formula. Okay, so formulas are exactly the same except for that sign change here. So just keep that in mind, and the way we're going to apply those formulas to a problem like this is what I want you to try and think of is how can I rewrite 15 as either a sum or a difference of two angles of unit circle problems that we've been doing for chapter after chapter after chapter. So what I want to rewrite the cosine as is the cosine, it's the same thing as 60 minus 45, correct? And I know I can figure out the sine and the cosine for 60 degrees, and I can figure out the sine and the cosine for 45 degrees because those are both unit circle questions. So instead of writing 15, I'm going to write 60 over 45, or 60 minus 45. And what I'm going to do is use this formula now. So I'm going to turn this into cosine 60 cosine 45 plus sine 60 sine 45. And I know all four of those functions, this, and this from the unit circle. And I'm just using my formula for subtracting two angles and cosine. Make sure that this is an addition sign here. So now we're just thinking unit circle stuff. So cosine of 60 degrees, that's 60 degrees on the unit circle. It's the x value, which is 1/2. Cosine of 45 is radical 2 over 2. Sine of 60 degrees, that's the y value, so radical 3 over 2. And sine of 45 is also radical 2 over 2. So remember, when you multiply fractions, you multiply straight across. You do top times top and also bottom times bottom. So 1 times radical 2 is just radical 2. And radical 3 times radical 2 is radical 6. And the way we're going to write our answer is radical 2 plus radical 6 all over 4. So that's how those formulas kind of apply to problems like this. So how about cosine of 5 pi over 12? So 5 pi over 12 is not a unit circle radian measure that we're familiar with. So what we have to do is try and figure out, are there two different radian measures that I can use that I can either add or subtract to get cosine? So this is actually the same thing as cosine of 2 pi over 12 plus 3 pi over 12. That adds together to be 5 pi over 12. And yeah, both of those reduce. So that actually is the same thing as cosine of pi over 6 and cosine of pi over 4. So remember, pi over 6 is our 30-degree angle. Pi over 4 is our 45-degree angle. I can answer both of those things using the unit circle. And that's going to help me figure out this 5 pi over 12. And so sometimes the hardest part is coming up with two different angles that you're familiar with using the unit circle to add up to or subtract to what you're given. So don't be frustrated with that. Just kind of give it a few minutes to think about and do some trial and error. This one was hard because these fractions both reduce. This one and this one turns into pi over 6 and pi over 4. Okay, so again, what I'm going to do is apply my formula here. And what this is going to become is cosine of pi over 6 times cosine of pi over 4 minus sine pi over 6 times sine pi over 4. So that's just applying the formula. Be careful again. Remember, we're adding here, so in our formula we're subtracting. Yeah, you'll have to have those memorized, so start adding it to your unit circle now on the back side of your unit circle where you're keeping a list of all the stuff you need to have memorized. So cosine of pi over 6, that's our 30-degree angle, so that is radical 3 over 2 is the x value. Pi over 4 is our 45-degree angle, so radical 2 over 2. Sine of pi over 6, again, that's 30 degrees, so the y value there is 1/2. And sine of pi over 4 is also radical 2 over 2. So remember, multiply fractions, straight across, straight across. It's going to give us radical 6 over 4 and radical 2 over 4 And the way I write my answer is radical 6 minus radical 2 over 4. They have a common denominator, so you can combine them. Okay, let's try one more. So what you have to do here is recognize that this is a formula being used. So how can I rewrite it using one of these? Is it cosine of a minus b or is it cosine of a plus b? So that's what you have to figure out using the formula. Since this is a minus here, I know that this is the same thing as cosine of something plus something. Okay, and what I have to recognize here is that in the formula, this is the a, this is the b, this is the a, this is the b. So my a is actually 87, and my b is 93. So this is going to equal cosine of, when you add 87 and 93 together, that actually gives you 180. And cosine of 180 is another unit circle question. I know that the x value there is -1. Okay, you guys, so final thing that I want to talk about, I'm going to skip these cofunction identities. Yeah, these are review, and these are things that we already remember. So remember when there's a function like sine, if the co is in front of it for cosine, then those are the relationships. So tangent and cotangent, you just do 90 minus theta. So those are function identities that we have already learned in chapter 1. I'm going to skip those for a second, and I'm going to move on to this last problem here on the back page. Okay.
And so here we've got two different ratios. One of them is sine, one of them is cosine, and it's given in the question that both of these angles are in quadrant 2. And then find cosine of s plus t. And so as you know, we've got a formula for cosine of s plus t. Cosine s plus t equals cosine s times cosine t minus, be careful of the switcheroo, sine s times sine t. So I'm going to apply this formula, and what's weird about this problem is that I'm given sine of s, which is 3/5, so that can go in right here, and I'm also given cosine of t, which can go right here, but I don't know what cosine s is or sine of t is. So here's where drawing a sketch in the correct quadrant is going to be helpful. So these are both in quadrant 2. It says both of them are. And so what I'm going to do is draw two triangles, both of which are in quadrant 2. And one of them looks like so. This is S. And I have another one in quadrant 2. This is T. And I'm going to label my stuff. So just remember that sine is y over r. That makes the y value 3. The r is 5. And then by Pythagorean theorem, you can find that this is 4. Just beware that this is negative because it's in quadrant 2. So make sure that you got a negative sign there with the 4. Same thing over here for cosine. This is x, this is r. Remember, r is always positive because it's the hypotenuse. That's my 13. This is a -12. That's why the cosine in quadrant 2 is negative. It goes with the x value. And then again, by Pythagorean theorem, you can find this y value, which is 5. Using a ton of Pythagorean theorem here. So now what I can do is use my formula that I wrote over there. So I have cosine of s plus t. Again, is cosine s times cosine t minus sine s times sine t. And I just have to plug in all my stuff now. So for s, I'm looking at this triangle. And for t, I'm looking at this triangle. Remember, some of the info is given up here, but not all of it. So in this case, I have cosine of s, and I'm looking at my s triangle here, which is x over r, so -4/5. Cosine of t, I'm looking right here, that's x over r, which is -12 over 13, minus, for sine of s, I'm looking right here, sine is y over r, so that's 3/5. And then sine of t, again, this is this triangle, it's y over r, which is 5 over 13. And remember how to multiply fractions. You do top times top and bottom times bottom, so that makes this over 65. -4 times -12 is +48. Again, the denominator here is 65, so 3 times 5 is 15. 48 minus 15 is 33 over 65. Boom, shakalaka, we're done. Thank you guys for watching. Have a great night. I'll see you tomorrow.